Hello students. So now we are going to start with numerical part of this chapter number 9, that is light reflection and refraction. So as we all know, maximum in question paper one or the other sum will be asked or the numerical will be asked. It will be from light reflection and refraction chapter, or it may be sometime from electricity chapter. So very important to solve these numerical parts. These questions will be very easy. Just we have to understand the question and we should know which formula we should use in that question. So now we are going to start this numerical part first. And in this chapter, first we are going to start with the mirrors, that is convex mirror and concave mirror. So now today we are going to solve our first sum of this convex mirror. So the sum is a convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. While reading any sum, you have to read it very carefully and try to understand what they are asking, what is given in the numerical and what you have to find out. So see here, convex mirror used for rear view on automobile has radius of curvature 3 meter. So here radius of curvature is given. If bus is located at 5 meter from this mirror, if bus is located at 5 meter from this mirror, so our mirror is convex mirror and bus, so bus is our object, and which is located at 5 meter from this mirror, means this 5 meter is the distance of this bus, is nothing but object distance. So we have object distance and we have radius of curvature. Find the position, nature and size of the image. So here by using these two values, that is radius of curvature and the object distance, we have to find out the position, nature and size of the image. So to find out the position of the image, we have to find out V, that is image distance. And to find out nature and size of the image, we have to find out magnification. If you know the value of magnification, then by seeing the value, it is positive, negative, less than 1 or more than 1, we will understand the nature. Nature means it is erect or it is inverted or it is virtual or it is real. That is called nature. And also we will understand the size. Size means diminished or enlarged. So by seeing the value of magnification, these two we can answer. So for this sum, we have to find out V value for position and M value for nature and size of the image. So first we will write what is given in this numerical, and then we will see which formula we can use. So we have radius of curvature. So I'll write it here, given. So what is given? The first one, that is radius of curvature. So I'll write it here, radius of curvature, and it is how much? It is 3 meter. So we know radius of curvature, it is given by capital R. So we will write it 3.00 meter. So write down the unit also, it will be easy for you people to understood the sum. So write down 3.00 meter. So next here object distance is given. So write down second, that is object distance. So I will write object distance, which is denoted by the letter U. So we will write it U, and how much it is? It is 5 meter. So I wrote both the values. So here you can see object distance is 5 meter and radius of curvature is 3 meters. So I wrote both. And then again here what we have to find out? We have to find out position. So as I told, we have to find out image distance. So for that I'll write image distance. And what is the symbol for image distance? It is V. So I'll write it V, and it is question mark. This we have to find out. Then again what I told you to find out. To find out nature and size, we should know magnification. So I'll write it here, magnification. Magnification symbol is small m. So I'll bracket write small m is equals to question mark. So these two we have to find out, and radius of curvature and object distance we have 3 meter and 5 meter. Now before going to find out this V value, first we will find out focal length, that is by using this radius of curvature. So if you see this radius of curvature, we know the formula, that is radius of curvature R is equals to focal length, that is F, divided by 2. So if this is our convex mirror and this is our principal axis, then this will be the center of this mirror, and this will be the center of curvature. This is the center of curvature. Then the radius of curvature is nothing but this whole distance. This is called as r, radius of curvature, which is 3 meter. And focal length will be somewhere in the center here. This is principal focus, actually, that is capital F. This is principal focus. And the distance from this center of the lens to this principal focus, it is called as our focal length. So this is our focal length, that is small f. So here I will write this is P, pole, center. The distance from pole to this principal focus is, that is small f, focal length, and the distance from pole to center of this curvature is capital R. So always remember, focal length will be half of this radius of curvature, or radius of curvature will be double of the focal length, and therefore we can use this formula, capital R is equals to f by 2. So by using this formula we can easily find out focal length. So how to find out focal length here? This same formula we can write it like this. So I'll write or, and if I take this f on the other side, small f, focal length, is equals to, this will be capital R divided by 2. So like this we can rearrange our formula. So use this rearranged formula and find out focal length. So therefore I will substitute the values. So f, focal length, is equals to, what is our radius of curvature? It is 3. So that is 3, and it is divided by 2. So 3 divided by 2 meter. So this is our focal length. So we got f. We will not divide here this 3 by 2. We will use this f value as it is in our numerical, and afterwards we will divide. Now if you divide it, you will get a decimal value, then it will be difficult to solve this sum. Therefore as it is 3 by 2, we are going to use it into the sum. So let's start with the sum now. So here we are going to use our mirror formula. So I'll write down the formula. So the formula is 1 by V is equals to, 1 by V is equals to, we will make little bit of changes. First we will write the formula as it is, and then we will rearrange it. So formula is 1 by V plus 1 by U is equals to 1 by F. Now we will rearrange. Actually this is our formula, mirror formula. But in the question we have to find out V, and that's why we have to rearrange this whole formula. And after rearranging we can write as like this. So I'll write it here in front of this, that is 1 by V as it is, which we have to find out, is equals to, we will write 1 by F, and 1 by U we will shift that side. So it will be minus 1 by U. So this will be the formula which we are going to use in this sum. So now before substituting the values, one more thing which you have to remember is, if you see these all the values, radius of curvature, that is 3 meter, as I told in this diagram, if this is our lens, if this is our mirror, that is convex mirror, then this side, whatever distances we are going to measure, all should be in plus according to our sign conventions. So therefore this we have took positive as it is, we can keep. But whatever distance we will measure on this side, those all distances should be in the negative sign. Whatever distance, I'll repeat once again, whatever distance we will measure on left side, this is left side, and this side, it is the right side. So right side of this mirror, all this distance should be positive, and left side, all the distance whatever we are going to measure, all should be negative. And always our object will be on the left side, here on this principal axis. Therefore object distance should be always negative. In numerical, remember, they will not give any sign, only they will give the value. You have to think properly, imagine where will be our object, and then you have to decide the sign. So I will write the sign here. So write down the sign in front of this phi, that is negative phi. So remember this, you have to remember the sign. So always our object distance will be negative, and radius of curvature here for this convex mirror, it is positive. So I wrote this sign. Now we can substitute the values. So substitute the values. So I'll write it here, 1 by V as it is, because we don't know, we have to solve. And our F, what is our F? F is our 3 by 2. So I will write it here, 3 by 2, and then minus 1 by U. What is U? It is minus 5. So you can see here it is minus 5. Now this 3 by 2 we can rearrange, and we can shift this 2 to the upper side. Then we will get 1 by V is equals to, this will be 2 by 3. I hope you know how to do it. Reciprocal it will be. If you do the reciprocal of this 3 by 2, it will be 2 by 3. So 2 by 3 minus and minus will be plus, and then you write down 1 by 5. So now we got this 2 by 3 plus 1 by 5. Now what we have to do? We have to take the LCM of this 3 and 5. That we will do it here on the other side. So I'll write it here. So we are going to solve it here. So now I will write LCM of 3 and 5. So solve the LCM first. So I'll write it here 3, I'll write it 5. Write both the numbers which are there on the on the denominator, and divide this by the lowest prime number. So here I'll take first 3, 3 1s are 3. There is no 5 in the 3 table, so 5 as it is. Now take 5, 1 as it is, 5 1s are 5. So LCM will be, multiply these prime numbers, 3 into 5, and then the answer will be 3 5s are 15. So this is our LCM. Now use this LCM in this formula, that is 1 by V. So I will substitute 1 by V is equals to, so our LCM is what, 15. So I'll write it 15, and then here it is 3, and in 3 table it will be 3 5s are 15, and for 5 it will be 5 3s are 15. So like this you have to multiply, then it will be 2 5s are 10 plus 3 1s are will be 3, and this will be 1 by V is equals to 10 plus 3 will be 13, and it will be 15. So this is 1 by V, but we want only V. So if you find out V, this will be V is equals to 15 divided by 13. Now we will divide this 15 by 13, and we will find out the answer of this V. So I will divide here. So what we are going to do? We are going to divide 15 by 13. So see, 13 1s are 13. How much will remain? 2, and we will borrow 0. Then it will be point. 13 1s are again 13. Then minus, we will get here 7. Then it will be here 0. Take one more 0. 13 5s are, it is 65. So I'll write it here 65. Then again it will be 5. This will be again 0, and like this we can continue it. So now here we are going to stop it. So our answer, I will take it as 1.15. So here I will write V is equals to 1.15, that is meter. So we got here V value, that is our image distance. I hope you understood till here. Now remaining will solve on the next page. So now we got our V value. So V value is how much? 1.15 meter. So this is our V value. Now if you focus this value, it is in positive. This value is in positive. So as I have drawn the diagram, once again I will draw it. So like this, the diagram will be of convex mirror, and this is the principal axis, and it was here our center of curvature, somewhere here it was focus. This was the diagram, and our object was somewhere here. This was the object on the back side of this mirror, or I can say left side of this mirror. So that's why object distance we took negative, because left side, everything, all distance should be in negative. These all the distance should be in negative. So we took object distance negative. Now if you see, our image distance is in positive. We have got plus 1.15 meter, means our image should present on the other side of the mirror. I hope you are understanding. So this is the right side. So whatever distance we will measure on the right side will be in positive, and we have got our image distance in positive, means our image is present on the right side or on the other side of this mirror or back side of this mirror. So this is nothing but we got here position of this image. So here we can write the position. So the image is at 1.15 meter from mirror on the back side of the mirror. So here we got position of our image. Now we are going to see the size and nature, and for the size and nature we have to find out magnification. So we will use here magnification formula. So what is our magnification? So I'll write magnification, and the letter used to denote magnification is small m, is equals to, now we have two formulas, that is one is, that is height of the image divided by height of the object, or we can use minus v by u. So this formula, it is in terms of height of the object and image, and this formula, it is in the form of object distance and image distance. Now if you focus this sum, we don't have height of the image and height of the object, but we have image distance and object distance. Object distance already we have, image distance just now we find it out. So we will use this formula to find out magnification. So substitute the values. So now I will write it here. So magnification m is equals to minus, how much is v? V is just now we got, that is 1.15. And what is our u? U was 5 meter and it was in negative. So I'll write it 5.00 meter. Now see there, negative sign will get cancelled. It will become positive. So m is equals to positive 1.15 divided by 5, like this it will be. Now we have to divide this. If you remove this decimal sign on this other side, if you remove the decimal sign, then this will become 115, and on the numerator, on the denominator sign, it will be divided by 100, and therefore it will become 500. I hope you understood this. If you remove this decimal here, it will shift 2 digits on the right side, and there, because it is shifting 2 digits on the right side like this, here there will be multiply by 100, and like this we can do it. So it will become 115, and on the denominator side it will become 500, and now we can divide this 115 by this 500 and we will get the answer. So we will divide now. So I will write it here. So we will take inside 115 and here it will be 500. So see, 500 is bigger number, therefore we will take here 10 and then here it will be decimal. So 1150 means 500 2s are, it will be 1000. So I'll take 1000. So minus it will be 0, it will be 5, this will be 1, and this will be again here 0. It will be cancelled out because here there will be negative sign. Now again it is 150, so I'll take one more 0. And now if you see in 500 table, 500 into 3 will be 1500. So I will take 1500 and this will be 0. See, this whole thing will be cancelled and this will be our answer. So I will write here, magnification will be plus 0.23. So this was the answer for magnification. If you see this value of magnification, it is positive and it is less than 1. Therefore, I will write, therefore, the image is, what we can write, it is virtual. It is virtual erect. Virtual erect. And it is smaller in size. So I'll write it here. And it is smaller in size by a factor of 0.23. So it is smaller by a factor of 0.23. So here this was the complete answer for this sum. I hope you understood whole numerical. If you solve it step by step, you will not go wrong. Just you have to remember, you have to read it very carefully, find out what is given, and also find out what sign should be taken for object distance and image distance. And then take the formula, write it properly, substitute the values and find out. For this thing, you should know how to divide, then you should know how to find out the LCM. Even I have done this. I will do the next videos on the same mirrors, remaining all the sums also from NCERT book, even from the previous year question paper. All the sums I'm going to solve in my next videos. Please like and share my videos with your friends and subscribe my channel.